Good day, grade 12s, and welcome to your, second topic of the year for grade 12 mathematics. And in this session, we'll be revising the linear function, and then we'll be proceeding with the quadratic function, the hyperbola, as well as your exponential graph. From there on, we'll be moving on to functions and inverses. But for now, take a seat back, relax, and enjoy. Okay. So boys and girls, if you guys remember, this you're supposed to know from grade 9, we have the linear function or the straight line graph. And it is expressed or described by the following formula: y is equal to ax plus q, or some of you guys might have been describing it as y is equal to mx plus c. That being said, we're going to follow the y is equal to ax plus q. Okay. Now boys and girls, the a in this formula in y is equal to ax plus q represents what we call the slope or the gradient of the graph. And here, as you guys can see, as I've written here, if a is positive, boys and girls, the graph is increasing. And if a is negative, the graph is decreasing. Now moving on to our q value, we said that our q represents our y-intercept. And if you can remember, we'd find our y-intercept where x is equal to 0. Okay. Now, boys and girls, these are 3 marks for you guys. And in the 3 marks that you guys will be getting, let's just remember our domain and range. For a linear graph, a linear function or straight line function, the domain will always be x is an element of the reals. The range will always be x is an element of the reals, or you could always state that x is an element of from negative infinity to positive infinity, and for the range, y is an element of from negative infinity to positive infinity. That being said, boys and girls, we're going to move on to sketching a linear function. Now, how do we sketch a linear function? If you guys remember, we first have to find our x-intercept and our y-intercept. And to obtain our x-intercept, we make y equal to 0. To obtain our y-intercept, we make x equal to 0. And then from there on, we determine what way or what position our graph would take. Would it be increasing? Would it be decreasing? And by that, in order for us to determine that, we look at our a value. Now, boys and girls, we're going to move on to a certain aspect of these questions. And when looking at a certain aspect of these questions, boys and girls, we will be looking at determining the equation of a linear function. So the first type of question they can give you is they can ask you to determine the equation of a linear function given 2 points. And when you're given 2 points, boys and girls, that lie on the graph, what would you do? Step 1. You'd find the gradient of that graph using m is equal to y2 minus y1 over x2 minus x1. Now, boys and girls, it is quite essential for you guys to remember that the sequence of the coordinates matter. For example, let's say we have a point 1, 2 lying, and let's say this is point A and point B is, let's say, 3, 5. Now, it is quite important for me to put them in the proper sequence, right? So let's say I'm calculating the gradient of this graph. Let me show you what I mean. y2, so let's say this is 2 and this is 1. y2, so it's 5, minus y1, which is 2, all over x2, which is 3, minus x1. So you see how these are x1 and y1, and how these are x2 and y2. The sequence is very important. If you get this wrong, buddy, you will forget. You'll just somewhere go sleep maybe, or do something stupid because you will lose your marks. Please don't do that stupid mistake. Thank you very much. So carrying on, so we're determining the equation. So first you get your gradient of those 2 points. After that, you'll take that gradient and plug it in. So you'll plug it in as an a value. From there on, you'll take any one of those coordinates and plug in the x and y values. And from there on, boys and girls, as we said here, you will solve for q. You write your final answer for the equation in the form y is equal to ax plus q. Okay. Now they can also ask you to determine the equation of a linear function when they tell you that, okay, this line is parallel to another line and the gradient of that line is, for example, 2. You're supposed to remember that, oh, when I did analytical geometry last year, parallel lines had the same gradient. Thus, my line will have that gradient. So you will use the fact that parallel lines have the same gradient, therefore the values of A are the same. From there on, because they've given you the fact that it's your function is parallel to another function and they've given you another coordinate, what will you do? You'll take that one piece of coordinate and plug it into your y is equal to ax plus q formula, and you will solve for q because you have your a. We said that parallel lines have the same a. You have a coordinate, so that means you have an x value, you have a y value, you're solving for q. Then you put it into your standard form. And last but not least, boys and girls, they can ask you to determine the equation given a function, right? A straight line function. And he'll tell you that, okay, this line is perpendicular to this line, right? And they'll give you another point that lies on the graph or on the function. What would you do? Go back to analytical geometry. Remember in analytical geometry, we said that the gradient of perpendicular lines, the product of the gradient of perpendicular lines is equal to -1. As such, what would we do? We'd use that fact. We'd say m1 multiplied by m2 is equal to -1. We then use the gradient of the line, one of the lines that's given, and we'd solve for the gradient for our function, right? So basically, we'd get out a value. Fine. That being said, we would then use the point, excuse me, boys and girls, we would then use the point that lies on the function, and that point must have a y, an x and y value. We'd use that, and we would plug it in, boys and girls, to our y is equal to ax plus q formula, and we'd solve for q and put it into standard form. Now that's what you need to know for your straight line functions. We're going to do a few examples, and then from there on, we'll proceed to the quadratic function. For example, it says, determine the equation of, question 1I says, in the diagram below, determine the equation of g, right, f and h in the form g of x is equal to, so this is the form that they want it in, very important. So here, what do we see? We can see this point, it's on the y-axis, so therefore this point, excuse me, boys and girls, this point is 0, -5. So here we can see we're given 2 points that lie on the same graph. What would we do? We would follow this procedure. The procedure of the first thing that I've given, we're given 2 points. We'd first get the gradient, then we'd plug in a point into the y is equal to ax plus q formula, solve for q, standard form. So question 1. Let me use a different pen for question 1, boys and girls. Question 1I. We'd get the gradient. M is equal to y2 minus y1 over x2 minus x1. M is equal to, so let's start first. Let's make this point 1 and let's make this point 2. Okay, so 1, excuse me, boys and girls, so it's y2 minus y1. Okay, so it's -5 minus 1 all over, let's see, 0 minus 2. And we're supposed to have a positive, because this, as we can see here, this graph that we're looking at in question I is an increasing function, so we're supposed to have a positive gradient. If we don't have a positive gradient, we did something wrong. So we'd have here -6 over -2. I apologize for the noise of the dogs barking outside. 6 divided by 2 is 3. M is equal to 3. And then we'd move on to say, therefore, y is equal to 3x plus q. Now, if you could also, what's this called again? You're now going to use a different point that lies on this function. We're going to see that, okay, we can use this first point, y is equal to 1, and we can use 3x is equal to 2. We're going to solve for q, boys and girls. We said q is the y-intercept. We could have already just written -5, but let's just see if our answers make sense. Okay, and it does make sense indeed. So we're gonna solve for q. When we solve for q, 1 minus 3 times 2 is -5. Q is -5. Therefore, y is equal to 3x minus 5. Solved. There we go. Question 1, II. Question II. Okay, boys and girls. We're moving quickly here. Okay. It says here, determine the equation. Same thing. So of h. Okay. So we have h. We can see that h is a line that goes through. We have 2 points that are given to us. They say determine the equation of h and f. Okay. So we see we've got g here. We've got h. Is there an f? Can't really see an f. Okay. So we are looking at this graph now, boys and girls. Okay. Same procedure applies. We'll be looking for what? We will be looking at getting the gradient, plugging in, solving. Okay, let's go at it, boys and girls. So what we'll do is m is equal to y2 minus y1 over x2 minus x1. M is equal to, what is y2? So let's just make this 2 and let's make this 0.1. Okay, so we'd have -6 minus 2 over 1 minus 3. 1 minus minus 3. So therefore m is equal to -8 over 4. M is equal to -2. Does it make sense? Yes, because why? I am supposed to be having a negative answer because my function is decreasing. That's the reasoning you're supposed to go for. Always ask yourself, quiz yourself. So therefore y is equal to -2x plus q. Now from there on, let's plug in a point. We can plug in a point at x and a point at y. What point are we going to be using? You can use any one at random. Let me just use point 2. And y is -6 and x is 1. So we'll have -6 is equal to 2, 1 plus q. So -2, -4 is equal to q. Therefore y is equal to -2x minus 4. There we go, ladies and gentlemen. Straightforward, straight to the point. Yeah, a good 3 easy 3 marks. 3 punte. Maaklike 3 punte ookie. Okay, very easy 3 marks. Let's move on to the next part of the question. And it says here, question 2, in the diagram, line x minus 2y is equal to 3 cuts q and s. So it cuts q and s. So this is the line. Okay. And line x plus y minus y is cuts p and r. Cuts p and r, right? The two lines intersect at t, fine. They say, give the coordinates of q and s. We can see q is an x-intercept. We can see q is an x-intercept. S is a y-intercept. Okay. So first, let's deal with what's given to us. So we are told, in question 2a, let me just quickly use a different color pen. In question 2a, we are told, what are we told? We're told that this line, the q and s line, is described by this function, x minus 2y. Let me just quickly write it properly. Boys and girls, I apologize. X minus 2y is equal to 3. Now, what is the frickin' standard form I taught you guys? I apologize for that word, but it's not even a swear word, but some people just tend to. Anyways, so what is the word that we're going to be using? I'm sorry, what is the standard form that I've taught you guys again? Y is equal to ax plus q. So let's make y the subject of the formula. So what would we do? We would have -2y is equal to 3 minus x divide both sides by -2, -2, -2. We then have y is equal to, okay, we have y is equal to -3/2 minus x minus 2. So this, a negative divided by a negative, both would be positive. As such, we'll then have what we have, what we call x. So this changes to a positive definitely. So we'd have x over 2, right, minus 3/2. What we could also do, boys and girls, in case you guys are a bit intimidated by it, what you could always do is have a common denominator, and you can have x minus 3. And that's your function. Okay. Boys and girls, we then have what we call, what's this called again? We then have what we call, solving for Q and S. We've put it into standard form. That's 1 mark. Solving for Q and S. Q and S are x-intercepts. So x and y-intercepts. To solve for your y-intercept, make x equal to 0. So y-intercept, y-int. Let me just quickly make it in blue. Forgive me. So for your y-intercept, your y-int, y-intercept. So for your y-intercept, make x equal to 0. So therefore here, we would have y is equal to 0 minus 3/2. Y is equal to -3/2. Therefore, what would be your y-intercept? S would be your y-intercept. Therefore, S has the coordinates 0, -3/2. Now we move on, boys and girls, to another important part. We're solving for our x-intercept. So for our x-intercept, boys and girls, we make what? We make y equal to 0. I know I sound like a broken record, but like it really helps. Okay. Now from there on, make y equal to 0. So here's our formula. This is our formula, boys and girls, just in case you've forgotten. Excuse me, let me just quickly try to get this out. So we'd have 0 is equal to x minus 3/2 multiply by 2, multiply by 2. 0 is equal to x minus 3. X is equal to 3. Thus, 0. Thus, 3, 0 is another point. And what point is that? That's point Q. That being said, a mark for getting to standard form, a mark for getting to this point, and solving. So that's a good 4 marks. Usually 3 marks, so it's a bit much this time. Now we're moving on to question B, which asks for the coordinates of P. P lies in this function. P lies in this function. And it's quite important for us, boys and girls, to remember when P lies in this function, we then have to deal with this. We're going to be following the same procedure I followed. Make y the subject of the formula. In this case, it would be very easy. Okay. So, question B. Here's question B. And in question B, it says x plus y is equal to -1. So it says x plus y is equal to -1. Make y the subject of the formula. Y is equal to -1 minus x. And this is your formula. Now, this being your formula, they want you to find the coordinates of P. What is P? P is an x-intercept. P is a x-intercept. Therefore, make y equal to 0. How do we proceed? 0 is equal to -1 minus x. X is equal to -1. Therefore, P is equal to -1, 0. There we go. Quick and easy 2 marks. It's even a 1 mark. I was being way too generous with this. Okay. Therefore, we move on to question C. What does question C demand of us, boys and girls? Question C looks at your coordinates of R. And what is r? R is, as we see, the y-intercept of this function. It's the y-intercept of this function, boys and girls. It's the y-intercept of this line. So how do we find the y-intercept of this line? We find the y-intercept of this line, boys and girls, by making x. So y-intercept, to make the y-intercept, to find the y-intercept, y-intercept is equal to r. It's equal to r. Therefore, make x equal to 0. As such, y is equal to negative 1 minus 0. Y is equal to negative 1. Therefore, r is equal to 0, which is x, negative 1. That's your r coordinate. Easy, 1 mark. Moving on to the next one. We found the coordinates of r. So D. Question D says, calculate the values of x for which the lines are increasing. So from which values of x are the lines increasing? So where are they increasing? For which values of x is the line increasing? Is this increasing? It's never increasing. But this increases from x is an element of negative infinity to positive infinity. So when they talk about the values of x, they're essentially talking about what? They're essentially talking about the domain. And boys and girls, I taught you the domain for a straight line will always be as such. X is an element of the reals, or x is an element of from negative infinity to positive infinity. That's your quick 1 mark. Now, boys and girls, in the next session, as you guys can see, I'm ready for you guys. We're moving on to the parabola. I want to stop the video here. Please do ask questions, revise. I'm rooting for you guys. This should have been a straightforward one, but if it wasn't, I'm still here to make it easy for you. God bless and all the best, boys and girls. Cheers.